In this next problem here, we've got Bob the Builder, and he likes to build small and large tool sheds. So you got a place for all your tools when you're doing housework. If there's a place that I like to put my tools, it's going to be a tool shed. So if I could have a tool shed, I'd call it Bob the Builder and have him manufacture one for me. Now, I don't know if I would want a large one or a small one, so let's think here. Well, he only has enough supplies to manufacture 30 total sheds. And the small sheds require 6 hours of his time to manufacture, and the large sheds require 30 hours. Woo! That's 5 times as much. You see that quick math there? 6 times 5 is 30. Oh, yeah, gotta love doing math. I do math even when I don't need to do math. Now, he has no more than 300 hours to work on these sheds. So 300 hours total time to make his large and small sheds. Now, if the small shed makes a profit of $130 and the large shed makes a profit of $250, well, how many should he make of each type to maximize his profit? Well, let's see here. I have a feeling that we could probably set up some constraints, write an objective function, find some corner points, plug them into that objective function, and figure out how many of each he should make. And you know what? I want to help Bob out. I like helping people out. So Bob the Builder needs our help. Let's help him out. Okay, let's start with the constraints. Now, he only has enough to manufacture 30 total sheds. So if we use S for our small sheds and we use L for our large sheds, we should have our small plus our large, and he only has enough to manufacture 30 total. So he could do less than 30, he could do equal to 30, so we're going to have less than or equal to 30. So the amount of small sheds plus the amount of large sheds should give us 30 total sheds at most. Now, each small shed requires 6 hours of time, and the large sheds require 30 hours of time. So 6 times the number of small sheds he makes plus 30 times the number of large sheds that he makes should be no more than 300 hours. So 300 hours or less. If it's a little less than 300 hours, he's got some time to kick back and watch some Hawks or maybe some Bears, maybe even the Bulls. Who knows? Who knows how much time he's going to have? Now, if the small shed makes a profit of $130 and the large shed makes a profit of $250, how many of each type should he build to maximize his profit? Well, we're talking about money there. 130, 250 of profit. We want to maximize the profit. That sounds like the objective function. So we're going to have 130 times the amount of small sheds plus 250 times the amount of large sheds, and that's going to be our profit. Now be careful when you're writing your variables. If you are a sloppy handwriting person, you may want to choose something other than S, unless you can distinguish between your S's. I know that my S's look like this, and my 5s I do in 2 pieces, so I make sure that I know the difference between the two. Don't mix them up. That can be very, very detrimental to your mathematics, especially on a test. So let's see here. We have our last 2 constraints. As usual so far, it's going to be S is greater than or equal to 0 because we can't make a negative number of sheds, and L is greater than or equal to 0. Let's graph these. Now the first thing I have to do is figure out what scale I want to go by on my graph, because it looks like I'm going to have to go by more than just ones. With this first equation, I have S plus L is less than or equal to 30, so if I do cover-up method, I get S is 30, and I get L is 30, and there's definitely not 30 boxes here. Now for the second one, I have 6x or 6s plus 30l is less than or equal to 300. Now if I cover up 30l and I take 300 divided by 6, well, that gives me 50. So I got to go even bigger than just 30 on here. I'm going to have to go with 50. Now I'm going to go by 5s because I know that both 50 and 30 are divisible by 5, so that'll make my life a little bit easier. So let's graph this first one here in black. Now if I'll have S equals 30 and L equals 30, so both my X and Y intercepts are going to be 30 and 30. So there's my first inequality, and we know we're shading it says less than 30, less than or equal to 30, so we're on the lower side. So we're shading over here. Now for the one in red, I'm going to have my X-intercept going to be 50, and my Y-intercept will be 10. Now since it's less than or equal to 300, I'll be shading below the line. And then lastly, our 2 blue ones, we have S is greater than or equal to 0, so that's like my X equals 0. That's a vertical line. and it's greater than, so I'm shading on this side. And then my L is greater than or equal to 0. That's like my Y equals 0. And I'll be shading above because it's greater than. And I can see once again that I have a quadrilateral. That's fun to say. Right there. That's where all of them are pointing. You notice the black arrows are pointing down here. The red arrows are pointing down. The blue arrows are pointing up and over to the right. So we got this right here. That's my feasible region. So let's look at our corner points. We have the always important 0, 0. Well, not really important because how much is he going to make if he does 0 work? He's going to make $0. Big old goose egg. Okay, let's see here. The next one, we have 0 and then up 2, but remember we're going by 5s. So this would be 0, 10. If we plug that into our objective function, well, 0 times 130 is 0, plus the 250 times 10 would give me 2,500. All right, now he's making some money. Next one we have is over 5 and up 1, so 5 times 5 is 25. And up 1 would be 5, so it's 25 small sheds and 5 large sheds. So I have 130 times 25 plus 250 times 5, which is going to give me 4,500. And lastly, so that was this guy here. Lastly, we have over 6 and up 0, so that's 6 times 5, which is 30 for my x, and 0 for my y, so 30 small sheds and 0 large sheds is going to give them 3,900. So it looks like, once again, a mixture of each one is going to give us our best profit. So he's going to have 25 small sheds and 5 large sheds. And there we have it. Make sure you write down your constraints. You graph them correctly. We find our 4 corner points, plug those into our objective function, find out our max profit or whatever the question may be asking, and we're done. Bippity boppity.